Alright, before we continue to our another multivariable calculus, and because we're discussing about derivative in previous video, I will recall you some Newton's law of motion, especially in second law in closed system, which in this system F is equals to m multiplied by a, and that it's equal to first derivative with respect to time for momentum, and for the assumption of closed system, the first derivative of mass is equals to 0. These two equations tell you about rate of change of mass is equals to 0, and then we have the dynamic of system, which is explained by its position dynamics with respect to time. So these all statements tell us about in mathematics called differential equation, which in general denote as the operator of derivative for x variable which may be matrix which equals some function which may be matrix which inside is x, and the other hand may be like this which have squared first derivative operator to x variable and gx function. In these two equations, the first equation is a linear differential equation for its linearity in D, but in the second one is generally non-linear differential equation. And f equals to 0 is called homogeneous, and so on for G. And then for derivative operator, if only d dx as usual, it's called ordinary differential, but for d is a partial differentiation, lead us to partial differential equation and so on. And now we have two questions. First, why physics mostly use this, and then how we solve these equations. The answer for the first question is that physics relates to dynamics, which is rate of change of something and its factor, which rate of change is about the differential both partial or ordinary, but the factor is about equation of motion. And the answer for the second question is generally there is no specific method, but sometimes we can only just analyze its characteristic which relate to equation of motion and every part of differential itself. For example, I have force total is equals to m multiplied by g factor, which g factor is equals to minus g at y direction, and in closed system which first derivative of mass is equals to 0, or just normally a gravitational motion nearby surface of planet. So that means by definition of force we will get that the acceleration part will lead to this equation which equals to the motion factor or minus mg y hat in Cartesian coordinate. And by linear independence between x hat and y hat in Cartesian, we will get two differential equations as this for both x and y. Now, if we assume that the g is constant for nearby surface of planet gravity, then by integration for both equations, we will get that in the x hat axis we will get the momentum x hat is equals to like this and is a constant, and we denote this as px or momentum in x hat direction. And the y part we will get this, which d here velocity at y hat at t is equals to 0 we denote as vyo, and a here for yo or y in initial. Notice that these three constant make 0, which now if we solving the x equation we will get the mx just like this. If we collect both results and we modify in x, we will get the t, which using this t to y, we will get y as this. Then we expand the quadratic term and collecting each term of x, which lead us to this. And now I define the first term as constant alpha, the second term which has x as constant beta, and the last one with x squared is a constant gamma. And notice that constant gamma is never negative, but for alpha and beta constant may negative. In this result, we get that this create a quadratic trajectory, which gradient of velocity always negative, and then if we take one point here, the distance between the 0 point is alpha, may negative or may positive. If we draw curve for y and x, then we will get this curve, which I draw dashed line here for continuity. This curve known as inverted parabola or just parabola. So the open problem now is, how about this equation which has initial condition x0 just like this, and these equations too with this initial condition, and for both initial velocity just equals to VO. And the last question is, how we check both equation characteristics without solving? These three questions is for the next video. That's how we dive into differential equation topics. I hope you enjoy this video. If you like this video, don't forget to share and subscribe, and see you later.